Hey everybody, I wanted to go over partially question 4.52 in Brown, Brown-Lemay-Burson, the textbook. And so in this case, it's asking which of the following are redox reactions. And so I wanted to give an idea how you can easily figure this out, and not only which are the redox reactions, but then figure out what's being oxidized and reduced. Okay, we're not going to do this other part, okay, for those that are not indicated. We're just going to stick to the redox part, okay, or the oxidation reduction part of it. Okay, so let's take a look at part A here. Okay, I already know from looking at this that this has to be a redox reaction. I'll do this in red because this is going from 0 to some value over here. Okay, if it's going from 0 to some value, I know that this is going to be a redox reaction. Okay, and so phosphorus is one of those things that is going to change oxidation state. And the thing to do is to look at phosphate. This is to look at H3PO4. Now, hydrogen is always a +1 with certain exceptions, and even more certain is oxygen at 2-. Okay, so this is 8- because it's 2- times 4. It's 8-, and then +1, so we're at 5-, so this has to be a 5+. So in this case, phosphorus is going from a 0 to a 5+. So phosphorus, if I can write a P, phosphorus is what's being oxidized here. Okay. Now, notice hydrogen is in a compound the whole way, and so hydrogen is probably not what's being oxidized, and what's being reduced. Oxygen are in compounds the whole way, and there's no peroxides or superoxides or anything like that, so it's probably not oxygen. So what I do is I kind of immediately draw my eye, because I've seen a lot of these, to the chlorine. So chlorine is here and here, so let's compare. This one's a little easier to do, so we'll do hydrogen is 1+, and chlorine now, because this is 1+, this must be 1- or -1. So here is -1, and then in H, so for HClO, H, this is 1+, and this is 2-. So all of this has to add up to the overall charge. The overall charge is 0 because it's a neutral compound. So chlorine in this case is a 1+. So it's going from a 1+ down to a 1-. So this is the thing that's being reduced. Okay. Now, part B. Let's get out the eraser here. Okay, so now for part B, again, maybe you pause the video and try to see if you can do this on your own. So for part B, we have an element and an element going to a compound. Immediately, because you have an element going into a compound, I would immediately say that it's got to be a redox reaction. Okay, because these two things have a oxidation state of 0. And so in this case, potassium bromide, okay, this is going to be a 1+, this is going to be a 1-. Okay, so what's being oxidized here? Okay, let's see, potassium is losing electrons. Its charge is going up because it's losing the negative. Minus a negative is a positive, so it's going to go up. So it's definitely a potassium is what's being oxidized. And now bromine is gaining electrons. Its charge is going down, so that means that bromine is being reduced. Okay. Part C, super straightforward, because for any combustion reaction is a redox reaction. That's what's so crazy about it. Okay, so what's reducing, what's oxidizing? Well, here's oxygen. Okay, oxygen is going from a 0 to a 2-, and here it's 2-. So that means that oxygen is being reduced. Okay. Oxygen almost always is the oxidizing agent. Okay, that's where it gets its name from, oxidizing agent. Okay, it's because oxygen causes oxidation, and so it's the oxidizing agent. The oxidizing agent is the thing that is always reduced. Okay, so now hydrogen doesn't change its oxidation state because it's going to be +1 here, and it's going to be +1 here. So the only other thing that can change oxidation state is carbon. Okay, so let's take a look down here. CH3, CH2OH. All of these, if this is +1, there's 6 hydrogens, so that's 6 plus from hydrogen and 2 minus from oxygen. So how many carbon? There's 2 carbons. So each carbon, well, there has to be a 4 minus, right? Because the carbon, all of these have to add up to 0, but there's 2 of them, so each carbon is a 2 minus charge. Over here, the carbon is a part of a compound, CO2. Oxygen is 2 minus. There's 2 of them. That's 4 minus. And so that means that carbon must be 4 plus. So carbon is the thing that's being oxidized because its charge is going from a 2 minus here to a 4 plus on this side. Okay. Now the last one, this one I can tell you if you go through, these are all ionic compounds, and you can see here zinc is 2 plus because chlorine is 1 minus, and sodium is 1 plus because hydroxide is 1 minus. Hydroxide doesn't change, so hydroxide is still 1 minus, and there's 2 of them, so zinc is 2 plus. Okay, we haven't found anything that's changing oxidation states, so this is not a redox reaction. Okay, so that is question 4.52 out of Brown, LeMay, Burston. Have a great day.